Back again at it. Okay, so this is the homework for lecture 25, finding scores given probabilities. Let's start with number 9. Now, pardon, I'm going to be toggling on my computer screen back and forth between the book and the homework. Here we go. It says for exercises 5 through 12, assume that adults have IQ scores that are normally distributed with a mean of 100 and a standard deviation of 15. Number 9 says find P10. All right, which is the IQ score separating the bottom 10% from the top 90%. All right, here we go. So we are finding P10, which is right here. Now, how did I get P10? P10 is the 10th percentile. Remember, P stands for percentile. So the 10th percentile separates the bottom 10%, oh, that's horrible writing, from the top 90%. So if I break down 90% into, I already know this is 50% right here, 0.50. 50 and 40 add up to 90, but this right here is the most important area that I need to look for. It's actually 0.4000. I actually looked that up backwards on my z-table. You are always interested in the area that goes from the center out to that line using our table. Now listen, different z-tables measure the areas in different ways. There's a z-table in your book that measures area in different ways. The z-table that I gave you, the worksheet, measures the area from the center to a specific line. Okay, so using that particular z-table, look up 0.4000, and I know I just wrote over it, but the closest z-score to 0.4000 is 1.28. And the reason I made it negative is because we are dealing with a negative z-score because it's to the left of the center. All right, so now we once again take the z-score formula, which is x minus mu divided by sigma, and we solve it for x. And when you solve it for x, you get x equals mu plus z times sigma. This is the equation we're going to be using throughout this entire homework, and that's exactly what I did right here. I took the mu, which is 100, then minus the 1.28 times the standard deviation of 15, and I got 80.8. That is the number, the actual raw score that separates the top 10% of data from the top 90% of data. 80.8 is the 10th percentile. So if on the rest of this homework or later on in the test, I ask you to find P10 or the 10th percentile, that's what you do, a measure of position. Number 10. Asks you, let me go back to the book really quickly here. Number 10 says find P60. I'll stop right there. P60 is right here. But most importantly, P60 is 10% past P50. Remember, P50 is always right here in the center. If you keep that in mind, that can be guidance for you. P50 is the 50th percentile, or the median, or the second quartile. It's always in the center of the curve. So P60 is 10 percentage points past that, so 0.1000. I look up this backwards on my z-table, and the closest z-score I find is 0.25. Please, at any moment, pause this video and look for yourself to confirm this. Okay? And you can always type to ask me questions. I've had 2 of you ask me questions this morning already, and I like it. I've been going back and forth with a few of you, hopefully helping you out. So I look up 0.25. It's the mean plus the z-score times the standard deviation, and I get an answer of 103.75. Number 11, find the IQ score separating the top 35% from the others. So the top 35%, that is right here. But this is the key to a question like this. This entire half of the graph has to add up to 50%. So 35 plus what gets me to 50, or better yet, 0.5 minus 0.35 leaves me with 0.15, or more importantly, 0.1500. I look up 0.1500 backwards on my z-table, and the closest z-score I find is 0.39. I plug it into my formula and get 105.85. All right, 12, the same thing right there. Let's get down to some of these word problems. 15B, 20B, 21B. We'll go over the homework with those because you might have some questions. As far as the bottom part of this homework, this was the worksheet right here. please hold on to this thought. We're going to be doing this in my next video as the actual part of the lesson. So hold on to that, but take a good look right now at the histograms versus the curves. All right, so we'll be going over this very shortly, but notice how some of them match a normal curve very well. Some of them do not match a normal curve very well. Some do, some don't. All right, we'll get to that. All right, back to the lecture at hand. 15B. Let's go over this homework. So 15 says, the standard doorway, and I'm on page 267. Have your book handy with me. Pause the video, get your book so you can read along with me. All right. The standard doorway height is 80 inches. And part B says, if a statistician designs a house so that all of the doorways have heights that are sufficient for all men except the tallest 5%, what doorway height would be used? All right, this is an important question because it's a special z-score. All right, so where are we? 15B. So all but the top 5% get excluded. 5% of the men's population have to bend their heads to get through the doorway. I know you have some friends in the high school who might have to bend their heads to get through the doorway. So 5% plus 45% adds up to 50%. That's the important area to find, the area from the center out to that line. Moral of the story for this entire homework. So I look up 0.4500 backwards, but I run into an issue. I find that it's 0.4500 is equidistant between these two z-scores, 1.64 and 1.65. What do you do when an area is directly in between two z-scores? Here's what you do. You average the two z-scores. Believe it or not, there's only two z-scores that we're going to be interested in where this happens. One of them is 1.645. Get used to that number. As random as that number seems, that z-score, it's going to become very familiar to us, 1.645. As a matter of fact, I'd like you all to look at your z-tables and look at the top right-hand corner of your z-tables right now. Look at the top right-hand corner. All right. Does it say for an area of 0.4500, use a z-score of? Wait for it, 1.645. There it is. So then I plug it into the formula, mu plus z times sigma, and I get 73.6 inches. So 73.6, that's what? 6'1.5" basically. So any man that is 6'1.5" or taller has to bend a little bit down to get through that doorway. That doesn't seem that tall. There's a lot of guys in our high school that are 6'1.5" or taller. We move right along. Number 20B. Let me go in the book. All right, based on sample results, assume that body temperatures are normally distributed with a mean of 98.2 and a standard deviation of 0.62. Physicians want to select the minimum temperature for requiring further medical tests. What should that temperature be if we only want 5% of healthy people to exceed it? That's the exact same question in terms of percentage, isn't it? 5% of healthy people, which means 0.4500 is what we're looking up. We get 1.645. We get a raw score temperature of 99.22. Done. I'm going to do one more homework question here, number 21B, and I think you got the gist. If we stipulate that a baby is premature, this is 21B, that a length of a pregnancy is in the lowest 4%, which number separates the lowest 4% from the others? So here is the lowest 4%. 4 plus 46 adds up to 50. So I look up 0.4600 backwards on my z-table. The closest z-score that I find is negative 1.75. All right, and it's negative once again because it's below the mean. Z-scores are positive above the mean. Z-scores are negative below the mean. Don't forget to write a negative z-score below the mean. So I plug in negative 1.75 and plug in the rest. And a baby is premature if it is born in 242 days or less. I hope this homework review has been helpful. Again, email me with any questions you have on Classroom. I'll get back to you.